Okay, so now there's the second type of van der Waals forces, which is dipole-dipole. Now, what is mean by dipole-dipole interaction? Let's see what does it mean that dipole-dipole interaction. Dipole-dipole interaction. Let's see what does it mean. Let's decode it. What does it mean? Dipole means polar, and other word means dipole, which means again polar, which means two polar. Interaction means interacting, meeting, interaction, like this. This is the interaction between positive and negative. So what does mean by dipole-dipole? Let's raise it. Let me raise it. What is dipole-dipole interaction? For dipole-dipole interaction, let's take an example of two dipole molecules. For example, this is HCl. This is HCl. And this is other HCl molecule. Right? It has partial negative charge. It has partial positive charge. So as for it as well, it has partial positive charge. It has partial negative charge. Now what happens? This chlorine atom attracts the hydrogen atom toward itself, like this. This hydrogen atom, chlorine attracts the hydrogen atom. So there is a polar dipole-dipole interaction between these two. This is dipole in nature. What means dipole? Dipole means, for example, this HCl molecule is also electrostatic in nature. What does mean by electrostatic? Which means it has a positive and negative charge. However, it's partial due to the one electronegative and one electropositive element. Chlorine, we know that the second most electronegative element. So this chlorine atom, when they do shearing of electron, it attracts the shear pair of electron toward itself, like negative charge toward itself, due to which gets a partial negative charge. So the interaction between two dipole moment is known as dipole-dipole. The dipole-dipole interaction. It's, however, it's weak in nature, but still it's happen, right? So let's include an example of water as well, because that is also in dipole-dipole interaction. Let's do it. Okay, so let's take an example of water molecule. Okay, so this is hydrogen, HOH, something like this. Wait. Oxygen, making a structure somewhere HOH. Then again HOH ion. So this OH ion attracts the hydrogen toward itself. In this way, the force of attraction, some sort of force do exist between them, which is known as dipole-dipole interaction or dipole forces, right? Okay, what is dipole forces? Dipole forces are the second most strongest forces after ion dipole interaction. These are the second most strongest forces after ion dipole interaction. So let's move ahead and discuss the third type of force or third type of interaction, which is ion-induced dipole. Now, what is meant by ion-induced dipole? Let's discuss the third type. Okay, let's see this molecule before moving ahead to discuss the ion dipole interaction. This happens when one, okay, look. For example, let me consider that it's rotating. It's very difficult to assign them the name. However, this is positive for a while. Consider this is negative. These are rotating and unable to give them a name. Right. So this positive charge attracts the negative charge toward itself. Right. This positive is attracting the negative toward itself. So this is dipole interaction. Where the negative partial negative charge of the one molecule attracts the partial positive charge of the other molecule, that is dipole interaction. Right. So let's move ahead and let's read it. Now the next one is that let's take a picture for it. Ion induced dipole. Ion induced dipole. Let's decode it then. Ion means has charge, whether it can be cation or anion. Induced mean non-polar. Induced basically mean non-polar in nature, which means this ion will make this non-polar molecule polar. However, it can be for a while, but this ion will make this molecule non-polar as polar molecule. We know that the chlorine, hydrogen, these are basically gases which hydrogen, chlorine, neon, and then helium. However, there is an exception that helium does not exist in diatomic force that we deal in the molecular orbital theory, but still we can consider it here. So chlorine, hydrogen, neon, argon, and a lot of other diatomic molecules, when they exist in liquid and solid form, so some sort of forces do exist between them. So let's deal with it. What forces exist between them? Let's deal with it. What is ion induced dipole? Let's discuss it. First of all, let me raise it. Okay, let's see this ion induced dipole. What is mean by ion? Let's take an example of sodium ion, which means Na. It has a positive charge in it. And then we have two chlorine molecules, diatomic molecule, chlorine, chlorine. We know that the electronegativity difference is 0, which is non-polar in nature. But when sodium atom attracts the chlorine atom toward itself, because it's positive and we know that it's negative and it's negative. So when the sodium atom attracts the chlorine atom toward itself, it gets the partial negative charge. It gets the partial positive charge. As you can see that now the dipole moment has been induced in them, due to which they attract each other. Right? One ion, when this sodium ion attracts the chlorine, it gets the partial negative, it gets the partial positive charge. Okay, let's take an example of bromine. Bromine, it has a negative charge. And then we take an example of oxygen molecule, which has double bond. Which a chlorine, mostly oxygen has double bond. So when this bromine atom will attract oxygen toward itself, it gets a partial positive charge, it gets the partial negative charge. Okay, it gets a partial negative charge when this bromine starts attracting towards itself. Okay, as you can see that this is two oxygen atom, okay, double bond. Now when this hydrogen atom will attract this oxygen atom, it will get the partial negative charge, positive charge, it will get the partial negative charge. Permanent dipole water molecule induced dipole. Okay, so this is dipole induced. No. This is an example of dipole induced dipole. We are here dealing with ion induced dipole. So this example is not right here, but still you can deal with this part. Maybe I have taken a wrong picture. So that I will be discussing as well, ion induced dipole, which is also known as instantaneous ion. Actually the exact name is instantaneous dipole induced dipole, which is dispersion and London forces that I'll be dealing as well. So just focus here that when one ion attracts the non-polar molecule, for example chlorine, bromine, argon, krypton, neon, that exist in diatomic form. So they induce the dipole moment in this molecule. So this is ion induced dipole. So let's raise it. Yeah.